In this lecture, we will be discussing about the cooling of transformers. When a transformer operates, losses will be developed. So, core loss and copper loss. So, winding and core gets heated. These losses will be associated with the production of heat energy. So, the winding and core of the transformer will get heated, and this heat has to be dissipated to the surrounding medium. And in a transformer, this heat dissipation occurs by three methods. They are conduction, convection, and radiation. So there are three methods for dissipating the heat in a transformer: conduction, convection, and radiation. Now what is conduction? Conduction is nothing but the heat transfer by means of direct contact between molecules. Molecules direct ആയിട്ട് ഒരു മെറ്റീരിയലിനുള്ളിൽ തന്നെ മോളിക്യൂൾസ് തമ്മിലുള്ള കോണ്ടാക്ട് കാരണവും ഫ്ലോ കാരണവും മൂവ്മെന്റ് കാരണവും ഹീറ്റിനെ ട്രാൻസ്ഫർ ചെയ്യുന്നതാണ് കണ്ടക്ഷൻ. സോ സെക്കൻഡ് വൺ ഇസ് കൺവെക്ഷൻ. കൺവെക്ഷൻ ഇസ് ദ ട്രാൻസ്ഫർ ഓഫ് ഹീറ്റ് ബൈ മീൻസ് ഓഫ് എ ഫ്ലൂയിഡ്. ഇറ്റ് ഇസ് ദ ട്രാൻസ്ഫർ ഓഫ് ഹീറ്റ് ബൈ മീൻസ് ഓഫ് എ ഫ്ലോയിങ് ഫ്ലൂയിഡ്. And third one is radiation. And in radiation, the heat energy is dissipated in the form of electromagnetic waves. So these three methods are used for heat dissipation in a transformer. So if we consider a transformer, this core loss and copper loss causes increase in temperature of core and the windings. So actually heat will be developed in the internal part of core and windings. First of all, the innermost parts of the core and windings will be heated. And from this part, we have to dissipate this heat to the surrounding atmosphere. And if we consider the path of heat flow from the innermost part of core and windings to the surrounding atmosphere, we can divide this path into four. So they are shown here. So first path is this one. So actually heat will be developed in the internal part of the core and windings. So from that internal most heated spots of core and windings, heat will first be transferred to the outer surface of core and windings. So core inde winding inde inner part aanu aadyam heated avunnu. So from that inner parts, heat will be transferred to the outer surface of this core and windings, which is the first path. And in the second path, from the outer surface of core and windings, the heat will be transferred to the transformer oil, which is in contact with the core and windings. So we know in a transformer, the core and winding assembly is placed inside a transformer tank, and this tank will be filled with transformer oil. So always core and winding assembly is immersed in the transformer oil. So from the surface of the core and windings, the heat will be transferred to the transformer oil. And in the third path, this transformer oil transfers the heat to the walls of the transformer tank. And finally, from the transformer tank walls, the heat will be dissipated into the surrounding air. So these are the four paths of heat flow in a transformer. And here, if we consider the first path, that is from the innermost part of core and windings to the outer surface. So this heat transfer occurs by means of conduction. Okay, so from a particular material to that particular material itself by means of movement of molecules, collision between molecules. So this is by means of conduction. So here in the second path, that heat transfer occurs by means of flowing of the transformer oil. So this is by means of convection. So in the third path also, the transformer oil is involved. So here also, the heat transfer is by means of convection. So if we consider the fourth path, that is from the walls of the transformer tank to the surrounding medium, here the heat dissipation occurs by both convection and radiation. So from the transformer tank wall, a part of the heat will be dissipated as electromagnetic waves, and also outside the transformer tank, it is the air surrounding the surrounding the transformer tank. There will be air. So air is also a fluid, and some of the heat will be carried by this air also. That is why we are saying that convection is also taking place there. So in the fourth path, heat is dissipated by means of convection, radiation, convection and radiation. So now we have to look into the effectiveness of transformer oil in cooling the transformer. So we know that the core and winding assembly of a transformer is immersed in the transformer oil inside the transformer tank. So what is the purpose of this transformer oil? Actually, the transformer oil is used for two purposes. First one, it acts as an insulating medium, and the second one is that it acts as a cooling medium. It is capable of carrying away the heat developed in the core and windings. So we have to look into the second purpose of the transformer oil, that is the transformer oil as a cooling medium. How effective the transformer oil as a cooling medium? So let us see. Transformer oil as a cooling medium. So we have already seen that the transformer oil dissipates heat by means of convection, and the specific heat dissipation of transformer oil due to convection. The specific heat dissipation due to convection by the transformer oil is given by this particular equation. 40.3 into theta by h the whole raised to 1 by 4. 40.3 into theta by h the whole raised to 1 by 4, where theta is the temperature difference between the heat dissipating surface and the oil. And h is the height of the heat dissipating surface. So this will be expressed in meters, and this is in degree Celsius. So if theta is the temperature of the dissipating surface with respect to the transformer oil, and if h is the height of that dissipating surface, then specific heat dissipation due to convection of transformer oil equals 40.3 into theta by h the whole raised to 1 by 4. So let us consider, usually the working temperature of transformer oil is about 50 to 60 degrees Celsius. So if we consider the value of theta is equal to 20 degrees Celsius, and the value of h from 0.5 meter to 1 meter, on substituting these values in this equation, we will get the value of lambda convection as varying from 80 watt per meter square degree Celsius to 100 watt per meter square degree Celsius. If we consider the corresponding value for air, for the same conditions, if air is used as the cooling medium, we will get the value of lambda convection as 8 watt per meter square degree Celsius. That means the transformer oil is 10 times more effective than the air as a cooling medium. So this is why we are using oil inside a transformer for the cooling purpose.